Thank you to our moderator and panelists for their excellent discussion of hot topics and initiatives in ADR. I would like to introduce our next and final panel, Risk of Implicit Bias in Artificial Intelligence and Predictive Analytics.
Good afternoon, everyone. I think it's the time for panel 8, saving the best for last. I think my co-panelists are waiting in the wings to join soon enough. Okay, I'm starting to see folks trickle in. Fantastic. So I'll start to kick off and assume that everyone will be on the screen momentarily. I'm Robin Nunn. I'm a partner at Morgan Lewis. I can't tell you how refreshing it is to be on the screen today with friends, experts in the field, and new friends. First of all, thank you to the speakers, CPR, and all of you for joining us for the last panel of the day. There's a lot of energy, great ideas, and I'm proud to be moderating this session, hopefully we'll be adding ideas into the introspection as to where we are in the world of artificial intelligence and bias risks. When Bert, Amy, and Apoorv and I were putting this panel together, we thought it had to be a discussion where we talked not just about artificial intelligence, which we've heard a lot about lately on the news, but the intersection of emerging technologies and bias. And we're going to talk about a grab bag of topics. And before we jump into our agenda, I'd like to say, if I had to kick us off and characterize the overall framework for AI and bias, I'd say that it's very much in flux, and that's even more true than ever this year. And there are a number of reasons for that. We've had a change in the administration. There are new personnel who are in charge of various agencies, and even news reports declaring systemic risk that we're going to talk about. But also there's just a number of really different rulemakings, either that have been commenced or that are being discussed. And those recommendations could have quite a significant effect on the way that companies and others develop AI programs. So there is a lot of action in this area. There's a lot of things happening. And please feel free to put any questions in the chat box. And without further ado, let's get started on the discussion. We wanted to put this panel together to share information as to what's happening at the intersection of machine learning and artificial intelligence, and how to think about opportunities and the risks and vulnerabilities. I'm honored to be on this panel and moderating this panel with 3 great professionals who touch the world of artificial intelligence, all in different ways. I think you're going to see and understand the different perspectives. So welcome Apoorv Agarwal, who is the CEO and founder of TextIQ, a top 100 AI company whose products are used by the largest enterprises and organizations. We also have Bert Kaminsky, who is a director within Google's legal organization and leads a team that supports commercial enterprises transactions for key industry segments of Google Cloud, including financial services, healthcare, and public sector. And last but not least, my compadre here virtually, Amy Nolan Needham, is the Assistant General Counsel of Manufacturing and Human Services at General Motors, focusing not only on defending GM's legal interests, but also on supporting GM's HR policy, DEI, and compliance initiatives. So we've got 3 great folks here who touch this area and these risks on a daily basis, and we're going to talk to them about how they're seeing the environment. So welcome to all of you. And let me set the stage for just another couple seconds. Today, we'll start off with just a brief explanation of artificial intelligence and how artificial intelligence may have biases. This will be sort of a factual initial introduction. We'll go from there into a couple of topics that our panelists will be able to speak on, as well as any other topics that you guys submit into the chat. We'll finish off with a few comments from our panelists with their idea, their takeaways on artificial intelligence and the potential biases that are out there. And we'll have, if we have time, we'll talk about some potential emerging technologies that are occurring and could affect artificial intelligence in the future. But it's going to be a whirlwind. I know we're the last session before the break, and we're really excited to talk with you all. So we'll do a brief introduction of artificial intelligence. Of course, it is a topic that people have been well acquainted with, especially in recent years, and we're not sure quite yet at this point where we have where things are going, but there's so much going on in this space, and we're really excited to sort of get started. So without further ado, I'll turn it over to the panelists. I'd love to hear from our panelists maybe perhaps an introduction about themselves, talk about how they got into artificial intelligence. Perhaps for the novices in the room, you could explain, what you work on, or someone who might not know the space, whatever you care to share. Who wants to get started?
I'll jump in first. Hi, I'm Amy Nolan Needham. As Robin mentioned, I'm the Assistant General Counsel of Manufacturing and HR at General Motors. AI touches GM, as you might imagine, in a number of different ways, but my clients that my teams support in particular, where this crosses over, are our HR clients and our talent acquisition clients in particular. And I know as we go on in the discussion, we'll talk a little bit about what's happening in the industry generally, but maybe some specifics as to what we're doing here at General Motors, some of the concerns we have, some of the ideas that we have, and then just everything that's going to touch us, from today moving forward. I think it's a very, as Robin mentioned, an incredibly evolving landscape. I'm very excited to hear Bert and Apoorv's comments today. We've spoken earlier, and these guys have some exciting ideas as well. So I'm thrilled to be here. Happy to be the final launching pad to everybody's weekend. Hopefully we're not keeping anyone from anything too important, but we're excited to be here to talk to you guys today. Thanks, Robin.
So I'll jump in. Thanks, Amy. So I'm Bert Kaminsky. I'm a director in legal of Google Cloud. So I've been in-house for over 20 years at major tech companies, including Oracle and GE Digital, and now Google. Before that, I was a litigator, changed my practice areas and the like. So artificial intelligence is not it's not this new thing in a sense. It is now becoming a really widely adopted emerging technology. It is almost a cliche, is that data is the new oil. Artificial intelligence runs off of data. In the old days, cloud systems and IT systems were systems of record that you stored data and you could just do some sorting and do some simple outputs. But companies are sitting on vast troves of data, and there's a huge amount of value in that data that's hidden. And the point of artificial intelligence is to unlock that value, to find discoveries and make insights into that data and improve things. It can improve quality. It can improve health outcomes. It can help cure cancer and the like. So AI is not a thing that's sitting on a desk. It is a capability that's being infused in all sorts of systems that formerly were not intelligent, and now are becoming increasingly so. So, Apoorv, this is exactly what you operate.
Yeah, thanks, Bert. Great to be on this panel. Great to see some familiar faces, and good to meet all the new people. I've been super privileged and excited and grateful to be associated with CPR now for a few years. In terms of my background, so I come from a very different background. I got my PhD in computer science from Columbia, specialized in natural language processing and machine learning, was also part of the original team that built IBM Watson. So I spent over 15 years tackling unstructured data like emails, all kinds of documents, and building AI systems to automate many of the manual tasks. In 2016, I started this company called TextIQ. It was based on my thesis research, and we entered the market by bringing something to bear which would automate privilege review. And then now we're expanding. In fact, one of the latest applications, interestingly enough, we've launched is about using AI to find unconscious bias, which we're very excited about. And less than a year ago, we were acquired by a larger company in the space called Relativity. So we're now actually part of Relativity and bringing AI to the Relativity platform. My 2 cents on AI, since we, this audience, we like to define things. It turns out it's actually really hard to define AI, because how do you define intelligence, right? a person who can multiply two large numbers, if we call that person intelligent, well, machines are way more intelligent than humans, right? So it's really hard to define AI. So one of the ways I like to think about AI is what are the purposes that AI serves in society? And one of the key purposes that we all care about is automation. Anything mundane, anything where a human feels like, oh, why am I doing this? And that, there's a pattern that can be replicated, can be automated using AI. However, not everything. There's still a lot of human thought process experience needed to make the final decisions, but a lot of the data processing and mundane tasks can in fact be automated using AI. So that's one of the purpose. And now we're seeing a few other purposes of AI, one which I'm very excited about, and that's in the field of accelerating creativity. So there's a lot of AI now out there that can create art, that can create music. We in fact did a panel at Text IQ about that. So because it's so hard to define AI, I like to think about it in terms of the purposes it's serving.
If I can just jump in on that one, Prabhu, that was great. It is a metaphor when we talk about artificial intelligence. It's not an intelligence as such. It's a mathematical process. And so it is not necessarily known, especially with machine learning, exactly how it's coming up with some of these results for creating this art. But what it does is it does a whole lot of calculations across with weights and parameters to get an output. And where we look at are the results. And then frankly, some aspects to explain how it got to those results to our users. AI does not have a moral compass. It doesn't have a self-awareness to know that it's doing something right or wrong, segueing a little bit into the bias issue here. It doesn't realize if it doesn't have sufficient data, or it has the wrong data, or the outcomes are harming some or not. This is why it's very incumbent on the developers and the users and the companies like our Arpurs to really monitor and design and ensure that the right outcomes are being used with this enormously powerful tool.
Well, thank you guys for setting the stage. There's clearly a lot to talk about here, and I'm so glad that we have Amy Bird-Napur here for a very timely and insightful discussion. I think we can all agree on this panel that we are not quite yet at the point where we have the ability to traverse the great world in space, but artificial intelligence has jumped a long way in recent years. And one great example that I always think of is our phones. When you have a product, and a lot of people nowadays have a phone that does facial recognition to unlock itself, it is an offshoot of the result of artificial intelligence, because at its core, AI is still a machine. It is a software that is, taken into account and takes into account data sets. And for those data sets, either make determinations or create algorithms for it to, interpret a potential result. But the one thing we have to keep in mind is that AI is still obviously based on what is given to it. It's based on learning and will still be based on who is inputting information, what type of information is being input, and what type of information is being excluded or not being particularly explained. And one way that we will get into AI, and hopefully this discussion, is the ways of teaching whether or not AI is being provided supervised or unsupervised learning, the difference between those two. I'm really excited about discussing supervised learning or data sets based with information that has been coded for the AI, and AI programs that are meant to take into account and make a determination, or unsupervised learning, where there's situations where AI is provided unset information, not data sets that have their own coding information, but unclustered information that allows for an AI program to interpret its own results based off of what it's finding. And that's where we're going to have a lot of discussion around, I think. And when there is information that a program is allowed or permitted to actually make its own determinations off of without the actual help of a data set guiding it to a certain result. So Bert, why don't I turn it back over to you before we go too far? Maybe I could ask you to please tell us what is bias in AI, since that's what we're all here to, sort of talk a little bit about.
Absolutely. Well, thank you, Robin. In any process that people work on, there can be a bias. So bias, of course, is not new for artificial intelligence. There'll be traditional ways of doing things, for example, in housing and healthcare and loans and credit and insurance. And so there's a long history among, that we're aware of whether existing human-led processes are leading to correct results by unbiased results. AI will derive off of the possible biases that exist in society, in the data sets that it uses, in the processes that it uses. And as our Purv talked about, it's an automation. And so once you automate a process that's existing, one has to be very careful about amplifying these type of biases that may exist within society and systems that are out there. So one of the international standards that define what bias is in the context of AI, I'll just read it, is a systemic difference in treatment of certain people, objects, or groups in comparison to others. And pretty simple explanation on that. I do want to say is that bias sometimes is not necessarily all bad. Sometimes there is a positive bias that you need to tweak systems to achieve better outcomes. For example, if your outcomes are underrepresenting women, you may want to, in a sense, bias the system positively to get a more balanced result in your output. So that's essentially how bias is represented in AI.
And Apoorv, do you want to jump in and talk a little bit about, how artificial intelligence can have biases?
Yeah, absolutely. And it's actually interesting that bias starts all the way when a human is defining the task that needs to be automated. So let's say we're building a machine learning algorithm to judge the creditworthiness of people. Now, creditworthiness is subjective. How do we define it? How do we define that objective? So the people in the room who are actually defining that objective, that's where it's all the way where humans are figuring out what is the task to be automated, where bias actually begins. So it starts all the way at the top. The second place where bias comes into a machine learning model, as to Bert's point, through the data. In the end, the machine is not thinking. It's literally replicating the human thought process of finding patterns in the data that exist. And if the data has patterns or implications that are biased, it's just mimicking the human thought process or the human output. So that's another area where bias can creep in. So in training these machine learning models, it's very important that we try to train it on as large of a data set and as diverse of a data set as possible, right? The third place where bias can come in, when humans are deciding which algorithm to use or what parameters and weights to use to train this model. That is the third place. So it's interesting and ironic that a lot of the bias that ends up being in an AI system is actually either induced by humans when they're coming up with the task, or when they're coming up with the algorithm, or what's called a feature extraction technique, converting unstructured data to a structured format that a computer can understand, and from the data.
That makes sense. And I'm going to jump to Amy soon, but I wanted to quickly just follow up on our Purv's point, Bert, with a question for you about what are the differences between fairness and bias? I hear a lot about fairness. I hear a lot about bias, and I'm curious in terms of, your perspective with respect to the differences there.
There is. They're really a bit two different things. I'm going to really simplify. A bias could be viewed as let's just say, a mathematical error. The data set is imperfect. The system design is not done well, and so there's a problem in sort of that AI system. Fairness could be that the system works perfectly, but it's an undesired result. Fairness, and meaning that it has a disparate impact on certain populations that wasn't designed for, anticipated, or expected. Fairness is really unfairness can come up in any number of ways, whether systems that deliver resources and allocate benefits or so may discriminate against certain groups. The quality of services may not be good for certain groups. That may be stereotyping or degrading and this type of thing. And so fairness is really a societal issue. It's a political issue that is highly contextualized in culture and geographies and in time and in different populations. It's not a universal definition of what is fair. And sometimes there's an irreconcilable difference or conflict between results from a machine that can benefit one population versus another, but it's not a machine learning problem. It's not an algorithmic problem. It's a social problem. And there's not a way that you can necessarily design a machine if they're going to be competing interests that fairness can be defined differently among groups. So that's kind of it at a high level.
Wow, Bert, that is tough. Now we're talking about societal issues. Let's take a step back. It's Friday. I'm going to turn it over to Amy if she wants to perhaps opine on that. But I'm really also curious about the popular uses of AI and how it has, GM incorporated the use of AI into certain functions. Now, Bert, I am going to come back to you because I do think we have to tackle this issue of the different types of bias. But let's just, take a break and jump to Amy and see about the popular uses. I'm starting to see questions coming into the chat too about this whole fairness bias issue. So I'll turn back to Bert and Apoorv to maybe talk a little bit more about that. But Amy, over to you. Do you have thoughts on this topic and popular uses of AI?
So definitely popular uses of AI, because Bert is just like making my head swim right now with all the implications here, and Apoorv as well. Obviously AI has been around for long enough that it's been used in a myriad of different fashions. As Apoorv mentioned before, how long has IBM been talking about Watson, right? We're going on decades now where AI has really been at the forefront. But now I think you're seeing it, and Bert touched on this as well, in medical advice, in risk management, in claims adjustments, in risk analysis, really across all sorts of industries. So for us at GM, one of the ways that we're incorporating AI in is in the talent acquisition area of HR. And I know that that's a super popular one. I know when Apoorv talks about, looking for bias, that certainly is something that comes into play when we're talking about using AI in a talent acquisition sphere. So imagine, companies like ours find other companies who create software. The war on talent has clearly been hyped. It's as high as it has been. And so every employer, I think, is looking for the advantage. How are they going to find the most capable workforce that's out there, especially in this day and age where we have LinkedIn, where we have social media, where we have websites, where we have online recruiters. Gone is the day of typing out your resume and sending it in, and maybe a company has 10 applicants for a job. Now they could have tens of thousands of applicants for a job. So how in the world, without taxing the resources of their HR department, are they going to cull through these? Are they going to get to the most qualified applicants? And that's where AI comes in. That's where that's where you can use these programs, and they have complications, obviously, and there are bias issues. I know we're going to talk about those later, but certainly I think when I think about my HR clients, like they are relying heavily on any way that they can possibly find to attract the best employees, find the best employees, cull through all of the data that comes at them, and screen and narrow down and create a profile of what they think is going to be the most successful candidate. But again, at every step of the way there, we're looking at what sort of biases are built into the platform. How are we testing those? How are we validating? And I know we're going to talk about that a little bit later, because I do think that AI just doesn't happen in a vacuum. It's not just, put a bunch of data in and voila, you're going to get the ideal candidate, right? There are just, I feel like so many checks and balances along the way that have to be put in place. And I'll be excited to hear the other panelists' thoughts on that as well. But for sure, with General Motors, when we talk about AI front and center, our talent acquisition group is, beating the drum on this.
That's great, Amy. And GM is in the forefront on this issue. I'm wondering if we can take a step back. And I think Orpurv is the expert running a top AI company. And maybe he can just help with understanding of what is and how does AI work, in fact. I mean, people talk about machine learning and black boxes and all this, sort of stuff. But, could you help us a little bit, just sort of, set the stage in terms of, how does AI work?
Sure. So just taking a step back, I'd love to, people use AI interchangeably with machine learning. And now we live in a world where deep learning is very popular. So if people don't mind, I just take a step back and clarify some of this terminology and then talk a bit about, how AI works. So if you think about AI, if you think of it as a circle, machine learning is a circle that's smaller and fully consumed within AI. So machine learning is part of AI. AI is, much older. So when humans started building rule-based systems, a rule-based system like if you see X, then do Y, that's a rule-based system, that's actually part of artificial intelligence. But machine learning, which is a subset, it's statistical in nature. So what the machine is doing, it's looking at the data, finding patterns, and based on statistics and mathematics, learning something about the data. So one way of thinking of machine learning is statistical AI. Machine learning doesn't have rule-based systems. And if you think of deep learning, that is yet another smaller circle within machine learning. So deep learning is just one of the many, many machine learning algorithms that are statistical in nature. You throw a bunch of data at it, maybe throw some labels, and it would learn how to categorize documents, for example, how to categorize documents into responsive, non-responsive, privileged, non-privileged, right? So it's just one of the many machine learning algorithms, right? And how do machines learn? It's a very, that in itself could be a panel. But at the highest level, at the most abstract level, one way of thinking about how machines learn really is that given data, they're looking for patterns in the data. They're doing all of this mathematics, looking for certain patterns. And a combination of patterns helps the machine classify a document, an object, an image into one of many categories. So it could be a cat, it could be a dog. If people are doing image classification, it could be responsive, non-responsive documents. But really, at the most basic foundation level, the machine looks at the data and finds patterns, right? And if these patterns are, of course, biased, then the machine will start picking up on these biases. So that's how machines or AI or statistical machine learning works.
If I could jump in on this, this is why it's hugely important if you have high risk use cases. Anything that affects the legal rights and fundamental rights of individuals. Again, things like healthcare, of finance, credit, these kind of uses, that you want to have the data set as rigorously labeled, so you don't run into this unknown of the machine of sorting through on a sort of machine learning basis and making undeterministic and unexpected results from what it's gleaning from. You want to have a much more of a rules-based system that is a little bit more transparent, a little bit more lineal, and one that's more explainable. I get. Do you agree, Apoorv? You would want to. You have different use cases for deep learning and machine learning, which can be used in ways of research and in other areas. But when you get to users using it for high risk applications, you need to structure it a little bit differently.
Yeah, definitely. And Bert, you actually open up another Pandora's box, which is there's this trade-off between quality, like performance, accuracy of an algorithm, and explainability. So while an algorithm like decision tree is explainable, if you actually train a deep learning model, which is a black box, on the same task and same data, most times the deep learning model will outperform the decision tree based model, which is more explainable. So there's also this tension between performance and explainability, and there's a huge lot of researchers actually working to bridge this gap, right? And then I see a question come up in chat. Can you give an example of deep learning versus machine learning? So deep learning is one of many machine learning algorithms, right? There are other machine learning algorithms like decision tree, logistic regression, support vector machines. So deep learning is a type of machine learning algorithm, if that answers the question.
That's great, Apoorv, and we're starting to get lots of questions. So I'm not sure if anyone wants to take the next one, which is, can the panel comment on how a user would be able to evaluate the potential for implicit bias with black box AI? We're also going to save 15 minutes at the end, so
yeah,
don't want to
I'll
mess
do
up the flow.
a really short. You see what the result is, and you compare the result against other benchmarks. There are a number of tools in the industry that are essentially debiasing tools, and you can do this. You can run the results of your system against what other desired or expected results are. You know, you can have what they call a ground truth, and then see how your AI system runs as compared to your desired results. That delta could be that implicit bias that's within the system. Then you go to your system, and then you tweak the parameters to change the output so it's no longer biased.
That's great, really helpful. Love the audience participation. You're keeping us all on our toes. Let me turn it over to Amy. What are the risks associated with bias in data output and AI-based algorithms, and what guardrails have you put into place to ensure against bias in the algorithms GM and your vendors are using?
So, I think that there are probably a myriad of risks depending on how you're using the AI and what platforms you're using and what sorts of programs, how you're accessing data, what you're using that data for. Off the top of my head, I think there are probably privacy implications if you're not accessing certain sorts of data without explicit permissions. Obviously, as the panelists talked about, there's a risk of bias in the output of the data that you're getting. I think that there's clearly risk if you're not properly validating the tools that you're using and sort of double checking the math. And I'll come back to that in a second. As an employment lawyer, these guys, Bert and Apoorv, talk at a level that's like here, right? I'm a simple labor lawyer. I look at things like, is what we're using having a disparate impact on certain classes of people? And if it is, why? Why is it? What's wrong? Is it the way that our people are using the tool? Is it the tool that itself that's creating this? And so at GM, there are a couple of safeguards we put in place, and I'll sort of use the simplistic terms. I'm sure there's a more technical way to talk about this. But the first thing we think about is human in loop. And so This means that we have a person involved at every step of the use of AI. So when, for example, with our recruiting teams, when they use these programs and the program, let's say, sets up a pyramid of first tier, second tier, third tier candidates, we look at those first tier candidates and they say, you know, this is the top 20% of the applicants that have come through. Okay, so we look at those. We have someone on staff who takes a look at that 20% and says, okay, these guys look pretty qualified. Let's look at tier 2 and tier 3. What did they answer that filtered them down to tier 2 or tier 3? And we have people go in and look. And so, for instance, we may be unnecessarily screening out qualified candidates because must live in Michigan might have been one of the criteria, right? So we see if they didn't live in Michigan, they're dropped to tier 2 or tier 3. When it turns out, holy cow, we've got a ton of people in tier 2 that are super qualified for this job. Maybe we need to think about that criteria that we put in that job description. Maybe it's not so necessary for us to have someone here in Michigan if we can get that super duper qualified person. And so it helps us to make sure that we're not having a disparate impact on certain classes of people, but at the same time, it helps us fine tune our job applications and our job requisitions to see, are we losing candidates that we would otherwise want because we've got some criteria in there that maybe isn't that important to the business, right? So that's one safeguard we put in place. And then the other is, we've talked about it here, I think either Bert or Proof mentioned it, explainable AI, right? It's kind of, I liken it to when I was first started learning to do algebra and the teacher said, you've got to show your work, right? So it's this idea, you know, when I think of the black box, simplistically, I'm thinking of it as the data goes in, it spits out an answer. I'm not really sure why it came to that answer. But that's what it gave me when I gave it this parameters. And so we reject a model of AI that doesn't have an explanation with it, right? If we are getting output that can't be explained, if the data or the program is saying you need to pick this candidate, this is the most qualified candidate, because we reject that and we say no, we need a deeper dive in here, because we do care about making sure that we have the most qualified people. We do care about whether or not the data that's coming out or the choices that come out have a disparate impact on protected classes or even just categories of people, like people who don't live in Michigan, right? We're not looking to screen out, you know, we love Michigan here at General Motors, but we're not looking to screen out folks who aren't from here when it's not necessary. And so those are a couple of the safeguards that we internally have put in place with our teams. But, you know, we're always looking for more, better, more sophisticated. You know, our team challenges themselves, you know, daily, weekly, annually to see what we're doing to make sure that we're doing it right and that we're doing it fair, that we're doing it legally, and that we're using this in a way that's also helping our talent acquisition folks, lessening their load and bringing the best folks to General Motors.
If I can jump in, Amy, you just described in great detail how GM does this, and it hits on all the areas that I see as sort of the perfect storm for AI bias risk. As I would put it, selection bias meets confirmation bias meets automation bias, and selection bias really are the data sets properly, your resumes and the attributes that you define in that, are those fair? Are those unbiased? Are those representative of what you want to achieve? The confirmation bias means is that when the system is developed and the users are using it, are they using this not just to reinforce their own pre-existing biases with Michigan residents versus non-Michigan residents? And then automation bias is where users tend to just rely on what an AI-based machine says, even if the thing can be a little bit inaccurate. These are some of the human cognitive biases that are out there, and it's great to see how you've described the processes to address those.
That's fantastic, Bert. You read my mind. I was literally going to ask you what are the different types of bias. We'll see if Apoorv can read my mind too. Because I'm going to ask him what are the challenges of addressing bias in AI in light of the latest laws and regulations addressing bias in AI. But before he answers, I do want to read the CLE code, which is counsel, COUNSEL. Again, that's counsel, like legal counsel, COUNSEL. The CLE code is counsel. And Apoorv, over to you.
Thanks, Robin. And actually, that question is related to what Alan is asking about developing a tool to surface implicit or unconscious bias, right? So it's very interesting, this problem of unconscious bias, because it's unconscious, right? And then if you were to get a team of people to look at manager reviews or cover letters of applicants, given that it's unconscious, it's hard to find, right? So we've given it a lot of thought, and we've come up with some objective signals. So there are a couple of signals we've come up with. One is around the kinds of words people are using for manager reviews, let's say, right? So are the words more to do with personality of a person, or are these words more to do with their work product, right? And a manager, if they're reviewing multiple people, when they review women versus men, do they mostly use personality words with women and use more work product related words for men, right? So that's a bias on the gender dimension, but you can do this evaluation also on other demographics, for example, ethnicity, right? So that's one of the objective criteria that we've come up with, and we've trained the machine to find work product related words and phrases versus personality related phrases, right? The other dimension is sentiment. When people are giving review, is their review more or less positive for a certain ethnicity or certain gender versus the other, right? So this is how our tool works. Given these reviews, it looks at what's the norm, what's the average, and are there anomalies? Is there a standard deviation from the average, right? And so we've done a few proof of concepts. We're doing this pro bono, and then the results are great. But going back to your question, Robin, now that we think about implementing something like this in the context of enterprise, we need to be very thoughtful, especially given the GDPR regulation, right? Concerns about privacy. How do we actually bring a tool or product like this to life, implement it? Of course, here our intention is for the better. We want to highlight what are the unconscious bias and make it a good cultural place to work and so on. But at the same time, there's a tension for it to be to maintain privacy, right? So I would say in bringing some of these systems to life, one of the key challenges that we have to deal with, especially given GDPR and CCPA, is implementing them in a way that keeps, in which privacy is preserved, if that makes sense.
That does. And Bert, I was just, briefly, yes, go for it.
I was just going to say is one could think just eliminate the attributes that one would think are problematic. Take out gender, take out race, take out age, take out all these things. The trouble with a simplistic approach like that is that there are all sorts of hidden other analogs that actually AI can pick up. And if you take out a lot of these other top level ones, you may actually be making the system more biased. You won't have a way to track and to know whether you're where in the process things are going awry. You won't have a good insight on how to recalibrate it, and so you could actually be ending up some worse results. So there's it's a complicated issue.
And Amy, I'm curious, are there some private initiatives that are going on that you've heard about addressing bias in AI?
So I think there are a lot of different projects going on around the world right now to address some of the issues that are coming up with AI, to harness the power of AI, to put guardrails in place. I know here at GM, our CEO, Mary Barra, and our general counsel, Craig Glidden, are involved with the Data and Trust Alliance. The alliance was established back in 2020. It's a group of large companies who, across a variety of industries, they come together to try to take a look at AI, to learn, to develop, to adopt what we believe are responsible AI practices. And so there's a thought at the Alliance that every data enterprise has an essential obligation to safeguard the data that comes to it. And so we've been involved here at General Motors. Our HR group really leaned in with the Alliance to help to create some safeguards in the employment context and in the employment selection context. And so, that was one of the projects that we worked on. I would also say, keep an eye out legislatively. I would think it was the city of New York probably is the most known piece of legislation that's come down around AI. I think they call it, I wrote it down here, the Automated Employment Decisions Tool Law that will take effect in January of next year. And that's going to require employers who use AI in their screening methodologies to give notice, to let people know. I think of it a lot in the same regards as the Fair Credit Reporting Act, right? If you're going to take an adverse decision based on the data that comes out, notice is going to have to be required, and also validation techniques. There are going to have to be audits by companies in New York City who use AI to show that things like bias are accounted for and measured. Probably the disparate impact isn't occurring on certain populations of people. And so I think when you talk about private initiatives, this isn't necessarily out in the broader business world, but I certainly think this is under scrutiny at a federal level, certainly at a state level, and then you see, cities and municipalities and saying, if you're going to use AI in your, get up with some safeguards.
That makes sense. And maybe I'll jump to Apoorv. I mean, we've talked so much about, legal implications, fairness, bias. Whose fault is it when AI goes wrong or makes a mistake?
So, yeah, I'm biased. I'm a computer scientist. I'm biased, no pun intended. But I think we put AI at a much higher pedestal and expect much more from AI than we do from humans. In the end, fact of the matter is, humans are also biased. There's only so many experiences we can gather in a lifetime, only so much we can read. And all of these things, how we grow up and so on, affects our perception of society and the world, which creates bias. With a machine, at least a machine doesn't have a limitation. It can read millions of documents in a few days. It can read documents in different languages, all kinds of languages, right? So that gives me hope that we can actually create machines that are, in comparison, less biased than humans, because they just by virtue of having the capability of looking at much more data than humans do, right? So to come back to your question, who's at fault? I mean, it's a really hard question. One way of mitigating, and I think Amy pointed using very thoughtful ways of bringing AI into production, is by putting a human layer on it. I think that's really important, right? Using AI as an assistant rather than a decision maker. Let the AI go through all of this data and make recommendations for whatever the end task is, but then have attorneys, have people who know about that domain, finance people who are making decisions about credit worthiness and so on, make the final call. Same with doctors, but let the AI come up with potential diagnosis or potential answers to what people are looking for, and having a layer of human, so to speak, decision making, right? So I think in that kind of setup, where AI is being used in an assistant and not as a decision maker, I think they're, a human, if something goes wrong, then, we can blame the human. In the end, they pull the trigger and call the shots.
I want to add to that. There's almost an implication when one says who's at fault, that it's static in time. If you're using an AI system over its life cycle, it's incumbent to monitor and update it over time. That the performance of an AI system can change and even degrade based on different data inputs, based on different use cases, based on different behaviors and requirements of the users. So by doing this, is that even if one would think that the engineer who created it did a bad job, or maybe they did a perfect job, over time the model will drift, and it's incumbent over time that people do ensure, just as Amy was saying, that you have ongoing validity of the system, ongoing fairness and non-biased checks, given the changing environment.
And Amy, I have one last planned question for you, and then we are already at our last 10 minutes. And then I'll give each panelist an opportunity to say any final thoughts and run through the questions in the chat. But Amy, before we close, just to piggyback on what Bert was saying, what are best practices as far as policies, procedures, and tools to detect and prevent AI bias?
So I hope they're best practices. Because they're the ones we're using. But Bert and Prove said, making sure that you keep humans involved, making sure you can show your work, making sure that your data is not disparately impacting certain groups of people, vetting your AI provider very thoroughly, making sure, make them show their work, make them show how they're getting to their answers. Think about indemnification agreements also with those providers if things go awry with the data that you're receiving. Look for resources. I think there are groups like the Alliance who are out there who are looking to try to put safeguards in place when it comes to data and AI and privacy. I think you're going to see a proliferation of these types of groups in the future. And keep an eye out for the legislation that comes down and make sure you're compliant with it. Like I said, New York City is coming out at the end of, or the beginning of next year, but I'm sure this is just the beginning of the laws we're going to see. So make sure that you're staying up.
Great. So lightning round, my favorite. I'm going to take all the questions in the chat, throw them out there, and then turn it to each panelist and go around. I think I've seen a question on any thoughts on how Daniel Kahneman's concept of noise impacts your works. Can't you program for a bias to achieve a fair result? What are the potential legal implications for bias in AI? How do we measure fairness? Lots and lots of questions out there. Last 7 minutes. Does anyone want to either answer those questions or give final thoughts as far as the takeaways for this program? It's been so much fun, and would love to hear a few minutes from everyone on any of those topics or anything else.
I'll jump right in and just say, look to see what the EEOC does. I know that they're leaning in on this as well as it comes to disparate impact. So when you talk about what are the legal implications, like I said, sort of self-interest doing to make sure that they're safeguarding the information that's in their possession, and look to see the EEOC take a strong position on this and what they think should and shouldn't be happening in this arena.
I'll give a quick overall thought. From an AI developer standpoint, it doesn't have to be the Google of the world. It could be GM or any other company that's building intelligent systems on their own, as becoming pretty widespread in their common tools out there. I suggest that there is a cross-functional team who validates the building and design of any AI tool. It's not just for engineers and anymore. You can have AI ethics boards that consists of social scientists and ethicists and theologians in some cases, lawyers, engineers, a whole political scientists, because you want to ensure that it just is not just working accurately, but it's also working fairly, and that it ends up being used in compliance with all of these laws that require privacy and other social goods.
I'll actually double down on that thought, because that is really the key point or key takeaway, I would say. As I mentioned earlier on the panel, bias starts all the way from humans defining the task. There are many operations that humans do in building these systems, maintaining them and understanding them, that a lot of the bias comes from humans. So to Bert's point, it's crucial that the team that's defining the task, the team that's building the system, the teams that's validating the results must be diverse. It's better to have a diverse team, and that will help reduce a lot of this bias. I think that's a great key takeaway. Thanks, Bert.
That's a great point.
Really excellent point, Apoorv. If I can put in one word, which is that, as Keith Lee said, artificial intelligence is going to change the world more than anything in human history, more than electricity, in his AI Superpowers book. And this program has really touched on a whole myriad of topics, but really there are many more topics that we could be covering in artificial intelligence. We're really just scratching the surface here, and I just hope that we will continue this dialogue and consider having more programming on our artificial intelligence, because AI is really permeating in every sector in society, every part of our economy, and there are going to be huge issues involved with artificial intelligence, and we need to be prepared as a nation and as a society for sweeping changes in technology. So without further ado, thank you so much all to our audience, to CPR, to our panelists, and everyone have a great weekend. Thanks so much.